Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, we're going to discuss the norm induced by the inner product. So this is a short topic, but very important. We are going to define the norm induced by an inner product, and we'll make some comments. So, given any inner product space, regardless if it's finite dimensional or any other vector space, if U is a vector in this inner product space, we will define the 2 norm of U as the square root of the inner product of U with itself. After all, note that if U is a real finite dimensional vector, the square root of the inner product of U in itself is given right here. But U sub k times U sub k is U sub k squared, and the square root of the sum of the squares is, by definition, the 2 norm of U. Similarly, for U being a complex finite dimensional vector, the inner product of U and itself square rooted is the square root of the sum of the entry U sub k conjugated times U sub k. However, Z times Z conjugate, which equals Z conjugate times Z, is equal to the absolute value of Z squared. So this is the sum of the absolute values of the entries squared, which is, once again, once we take the square root, the definition of the 2 norm for complex finite dimensional vectors. In this course, we are going to focus on using the inner product and its properties, and thus the most common norm we will use is the 2 norm. Also note that the other properties of the 2 norm follow from the properties of the inner product. Now, an important variation on this definition is that the inner product of U and itself is equal to the 2 norm of U squared. So, following this topic, you now know that the 2 norm is a norm induced by the inner product. You understand that this relationship is why we will continue to focus on using the 2 norm in this course. Here's the references, acknowledgments, the colophon, and a disclaimer. Cheers!